Welcome to yet another episode of Hydrology for People series. As you know, this program is initiative by National Institute of Hydrology to disseminate research outcomes of the institute to the masses. Today we have Dr. Vishal Singh with us. He is Scientist G and prominent scientist from Cryosphere and Climate Change Hydrology Division of National Institute of Hydrology. Before we proceed with Dr. Vishal Singh, let's take a look at a small video prepared for today's topic.
In the vast expanse of the Indian subcontinent, the delicate balance of nature is undergoing a profound transformation, and the repercussions are echoing through its water resources. The impact of climate change on India's water reservoirs, rivers, and aquifers is both palpable and alarming, casting a shadow on the very lifeblood of the nation. As temperatures soar and weather patterns become increasingly erratic, the traditional monsoon cycle, upon which India has historically relied, is undergoing a metamorphosis. The seasonal rains, once a predictable source of replenishment for rivers and groundwater, are becoming more unpredictable and extreme. This unpredictability disrupts agricultural schedules and exacerbates water scarcity issues across the country. Glacial retreat in the Himalayas, the source of several major rivers, further compounds the water crisis. The accelerated melting of glaciers not only reduces the overall volume of fresh water available, but also increases the risk of glacial lake outburst floods. Changing precipitation patterns are impacting the availability of surface water, affecting rivers and lakes that millions depend upon. In some regions, prolonged droughts have led to the depletion of water bodies, leaving communities grappling with acute water scarcity. The National Institute of Hydrology, through its Center for Cryosphere and Climate Change Studies, is working with advanced scientific knowledge to understanding the complex interactions between climate and the hydrological cycle. The center aims to contribute to the development of sustainable water resource management practices, adaptation strategies, and policies in the face of climate change. India stands at a critical juncture. The impact on its water resources is not just an environmental concern, but a multidimensional challenge that requires innovative solutions, political will, and the active participation of communities. The nation's ability to adapt and mitigate these changes will not only determine the well-being of its citizens, but will also shape the future of this vast and diverse land.
So, Dr. Vishal Singh, as you know, our glaciers are melting. Can you please tell us what impact the melting glaciers are contributing to the water resources, particularly the rivers dependent on the melting water?
So the Center for Cryosphere and Climate Change Studies has been established recently, and as per the objective of the centers, we are working in different river basins in the Himalaya. So as you know that the three major river basins corresponded to Himalayan river basins. One is Brahmaputra, then Ganga and Indus. So we have observed a significant warming in the Himalayan river basins. So because of that warming, the glaciers are accelerated in terms of retreating, and because of that the acceleration in terms of glacial melt runoff and snow melt runoff we are getting. So these are some climate change issues that in the very first term we have notified in the Himalayan river basins. Because of the receding of the glaciers, the acceleration in terms of snow melt runoff and glacial melt runoff we have observed in the downstream sections where we have the observation sites.
What difficulties scientists are facing to predict the impact of climate change on water resources?
So as you know that in Indian Himalayan river basins, basically the problem is the hydro observation measurements. So we have very less hydro observation sites in the Himalayan river basins. So a lot of uncertainties may be arrived in the modeling outcomes. So we have to overcome there, but still we are using some different techniques, and we are trying to establish more hydro observation sites, and we have already procured some hydro observation monitoring instruments. So we are going to establish there so that we can strengthen the hydro observation network over the glaciated region basically. So the real time parametric computation we can enhance, and in that way we can minimize the uncertainties in the final modeling outcomes.
Dr. Vishal Singh, I have gone through one of your research paper. It says that small glaciers are melting fast in compared to the bigger glaciers.
Yeah.
Can you please elaborate this?
Very good question you have asked. So we have analyzed recently, we have analyzed 3 river basins. The reason is that in some areas we have the glaciers in a very high elevation areas, like greater than 5,500 meter. So it is said that the glaciers which are situated at a very high elevation areas, like greater than 5,500, suppose that you can take a threshold of this particular elevation range, so that glaciers are less prone to capture warming and less prone to recede as compared to the glaciers which are situated in the moderate elevation ranges. So if you see the glaciers distribution over the Baspa river basin, so around 40 to 45% glacier area that is distributed below the 5,000 meter elevation ranges. So that is why these glaciers are prone to capture heat and prone to retreat. And we have also seen that the larger glaciers which are in larger size, they are receding actually, but because of the acceleration of the melt runoff, the area is not that much changing. But if you see the small size glaciers, so because of the acceleration of the glacier melt, ultimately they have lost their masses, and because of that the amount of discharge is reducing in terms of small glaciers.
What are the most important recommendations from you to the policy planners?
One is that we have to restrict the carbon emission in the Himalayan areas, and we have to control over the anthropogenic activities that is accelerated in recent past, like in few years we have deforested the Himalayan areas. Lot of deforestation is there, then agriculture expansion is there, and a lot of vehicle movement is increased. So we have to see in these anthropogenic activities, and we have to somewhere we have to restrict them. The second thing is that we have to apply an integrated approach to minimize the effect of glow event and other extreme event, especially in the Himalayan areas. Like we have to analyze hydrologic models to predict the behavior of the snow melt runoff and glacier melt runoff under the climate changing environment. For that we can utilize the IPCC based climate model data sets. So that climate model data sets can be utilized, and we can generate the future scenarios for stream flow. I mean how the stream flow is behaving like in the historical as well as in the future. If the climate extremity will be there, so how the runoff will be changed in the downstream sections. The third one is that the early warning flood system we should develop in that particular area, so that we can minimize the impact of the glow events. At NIH also we are working in this aspect. We are doing the field based experiments to enhance the accuracy of the early flood warning system. The drawback of the early flood warning system is the reliability of the forecast. So a lot of uncertainties are there because of the less amount of the data, or we can say we have a less observation network in the Himalayan areas. So first we have to strengthen our Himalayan areas with number of instruments that is required to measure the snow and glacier and cryosphere related parameters, so we can improve the accuracy of our early flood warning system. And where first we have to make a proper atlas kind of thing, like we have to map the vulnerable glacial lakes each and every year, and we have to identify which glacial lakes are increasing or decreasing and which are vulnerable. We can categorize highly vulnerable, low vulnerable, moderate vulnerable, and in this way we can make a classification, and based on that we can apply the management strategies in those vulnerable glacial lake areas or where the problem is there.
Thank you very much, Dr. Vishal Singh, for coming in our show.
Thank you.
So, Dr. Vishal Singh, who is telling us important information on climate change impact on our water resources. This is it for now. If you have any suggestions and recommendation, please write us on hydrologyforpeople@gmail.com. Dr. Vishal Singh, thank you very much for coming in our show.
Thank you.
Thank you.
Thank you.
Namaskar.